spotlight is strong with this one. All right, thanks. Yeah, I'm Davide, and today the talk is Hitchhiker Guide to MLOps. It's a bit of a hooky title, but I thought it was a good idea since we are in London, and it's one of my favorite books. And why do I have this title? It's not just the hook. The idea is MLOps, for those who don't know, machine learning operations, is becoming more and more hot. There is a lot of talks around companies, products, open source, non-open source, just a lot of it. And if you open your browser and Google it, it can be kind of scary, like if you're looking into the universe. And there is just way too much. So sometimes you just want like a couple of easy answers to get going and maybe get some ideas, especially if this is the first time you're starting with this topic, which was me some time ago, and hope that this will help some of you that are getting started in wanting to know more about MLOps. So if you don't have a towel, grab your notebook, which I did. These slides are made with a Jupyter notebook. I love it. So unsolicited, I'm going to say a little bit about me. Machine learning operations engineer at Massive Entertainment. We're one of the Ubisoft studios. Really proud developers of some AAA games like The Division, World in Conflicts. I don't know if anybody plays these. And now also working on games in the world of Avatar from James Cameron and Star Wars. Big fan. When I'm not at work doing machine learning, I'm also a guitarist in a metal band that I'm 100% sure none of you has ever heard of. Fortunately. That's not what should have happened. So, MLOps. I still get a question a lot, which is, do I need to care about it? And I get it from people within the field. And usually it's becoming a thing. People are starting to understand more about it. But usually I get it towards the end of a project when people have released their hard-worked machine learning model in production. And they're like, oh, well, there is actually more to this. Because I actually think one of the underrated part of this whole process, and we'll see it in a bit what all things that go around it are, is about what actually happens after you have released a product, this kind of little forgotten piece. And what I do is like I start talking about this kind of funny example, which is maybe some of you remember 2016 when Microsoft released a chatbot called Tay. I thought it was pretty fun at that time. So what happened, the idea was the chatbot was, had the possibility to interact with people and learn what it means to discuss with humans, chat, tweet, and so on. The idea is super awesome. The problem is that within 24 hours, something really wholesome and cute transformed into a genocidal racist, because human beings are tricky. So what happened? Then I thought about it, and I was like, okay, if I could go back in time, and I was the one releasing this chatbot, probably you wanted to set something like a KPI for when you had your model out there and was starting to train on new data, so the new tweets. And maybe this KPI was something like bot racism. And then perhaps you could set a threshold and be like, okay, if the value of this kind of racism metric that I'm tracking goes beyond a certain threshold, probably want to start taking a look and stop my model updating. Probably something has changed. Maybe the data is not what I expected, all that kind of stuff. And this kind of centers to almost like a philosophical question, but the main question, which is also the topic of this talk, is, do I need to monitor my machine learning system, which is one of the parts of MLOps? And I think the question is, in a world that is becoming more and more data-driven, sorry for the buzzword, data-informed, systems are making decisions autonomously, and just, we want that. We want machine learning to support all our processes. But do we want to let the models run by themselves in an unexpected world full of, all the unpredicted events, which are data in our case? Or do we want to keep an eye on the models and track what they're doing over time in case we need to go all Blade Runner on them? like sometimes you have to do. Here I wanted to stop a bit before we get into the whole part of the talk, and ask kind of a question, which is not what you're seeing here. This was asked to Dali. The question is, who has released a machine learning application model system to, let's say, production? All right. Who has released such a system without monitoring on it? Yeah, I don't know. I was young and I wanted to live on the edge, but I think it's time to move on. But I'm happy that I'm not alone. Yeah, we are all in the same place. All right, so what are we gonna talk? At the beginning, I'll just give a really short introduction of what DevOps and MLOps here, for those who have never heard about it, really a no panic introduction to start seeing what are the similarities and what goes in there. But then I'll focus on what I mentioned, monitoring. There is like the big part of this, and also I feel like the low-hanging fruit, like a really accessible part of this whole complicated stack. And I'm going to do it in a practical way. We'll show two tools that you can use, being one MLflow, that is a platform that can be used for tracking your systems, and one for monitoring on top of it called Grafana. And then I'll just conclude with some tips, some resources if anybody wants to look into this more, and hopefully questions if I manage to not go over time. So, DevOps. It has a similar name than MLOps, so there must be some similarities in here. This has been around for a long time. In traditional software development, it's all the tools and processes and all the best practices that help developers getting more collaborative, fast, reliable, being able to monitor, release, test, automate, all the things that go around making software. It's pretty good. Of course, things are changing because the world changes in terms of tech, infrastructure, and so on, but the ideas stays the same, and the objectives are those. But if we could just take it, since it's been around for so long, that'd be awesome. Talk would be over, MLOps solved. But things are not that easy. This is like a super simplified diagram of the differences between traditional software and machine learning. One, in traditional software, we could say that most of the challenges and the outcome of the release, let's say the outcome of your development depends on the code itself. In machine learning, we have two additional components. Of course, we have code. We have to write some Python. But we also have data. Data that comes in the system will affect how the code performs. And also we have things like, for example, parameters. So if we change parameters of a system from one run to the other, things can both either run or not, or they can run in different ways that can be really hard to predict. So there are additional challenges that are not present in traditional software. So what is MLOps? Here I wanted to quote a definition that was given, I think, last year in a Google paper where they start taking a look at what MLOps is. I think it's nice that finally they're starting to get some standardization in the definitions. And quoting, MLOps provides a set of standardized processes and technology capabilities for building, deploying, and operationalizing machine learning systems rapidly and reliably. So the definition is very similar to what DevOps is, but of course now we are dealing with these additional challenges. So this is a bit of a, again, kind of a diagram of, coming from the same paper, of what the different phases are. And I'm gonna go through most of them really quickly, because I wanna focus on the monitoring part that you see here on the top left. But if we start from the top, we have machine learning development. We know that we've all done it in our notebook and whatnot. Then there are components that deal with being able to now wrap our code that perhaps is not ready to just run on production. Wrap it in such a way that it can be trained on demand and can be scheduled, for example, the continuous training, or can be triggered on data, events, and whatnot. Then there is the part about actually being able to take now this model that we have trained, and it's able to train online over time, and actually deploy it, and being able to be queried, and predictions to be served. And then there is, last but not least, the continuous monitoring part. And it's important because, in my opinion, this is like, again, really the an appreciated step, because I've been myself in that situation before, where I have, let's say, 5 months to run a project, and all the focus goes into all the fun parts, which is data cleaning, crunching, all the features, models, and developing, and of course, people want to see the results, so you need to start training it, and you want to get data online, and you have to start deploying it, and then 4 months have passed, and you can't monitor it, and you're like, well, I guess that's it. Let's move on to the next project. But I think here the important part is that this last phase, and in general, this entire flow all has to exist end-to-end in order for your machine learning system to be able to run in a reliable way that it's safe and secure. So if you don't have this all stacked together and you don't start thinking in a, let's say, in an integrated way, in a MVP way, if you are thinking that kind of agile world, then things will not work the way you expect. Because there is a major issue, and there have been other talks the past days, and I love them. On Thursday, there were from Anovos, and then there were other talks from about the Great Expectations library to start tracking changes. Here I wanted to quote one of my favorite artists, changes. Nobody got the joke? Great. Things will inevitably change, and you cannot predict, especially data. If you have set yourself some expectations when you have developed your model and trained it, that certain things will work in a certain way, and now you got all this nice performance and things are working, they will not, 100% guaranteed. So maybe better get ready for it. This meme is terrible, I'll skip it. Yeah. All right, let's start with some practical stuff. I mentioned that I wanted to talk about MLflow. What is it? It's an open source platform that works with Python. Of course, we are here for PyData, but actually the nice part is that it works with a lot of other different systems. And the aim of this project is to standardize this set of tools and practices that go around this MLOps cycle that we mentioned before. I think what's interesting about MLflow is getting a lot of traction. I've seen more than 10 talks only on PyData in the past couple of years. When I did these slides, 5 million downloads on PyPy, 300 contributors. It's a pretty healthy infrastructure. It was originally developed by Databricks people, but now it's open source. And side note, I'm not affiliated to Databricks at all, but I think it's interesting if you're taking a tool in your project to know how healthy the system is, if you want to start investing time on this and hopefully getting something that can support your infrastructure for many years to come. Great keynote from today about supporting open source. So I think this is just an important topic to know. So what is it about? You can think of it as a system that contains different components, and they call them ML tracking, projects, models, and registry, and each of these kind of fulfills the different phases. Where tracking, let's say, which is the one that I want to focus the most on, is the one about monitoring the system, but then there are things for wrapping the code, being able to deploy it, being able to save models over time. And you can think of it as, at least the first part, this MLflow tracking, as kind of an extended login database that understands machine learning. And I'm gonna now show a little bit. Hope the image is not too small, maybe it is. So the system, at least for the tracking part, relies on two main concepts, experiments and runs. Now the experiment, let's say that is like the main container of your project. You could call it like weather forecaster 1. And then each run would be, for example, a new training run for this project. Let's say you used linear regression with this and this parameter on this data set on the 20th of June, and that is a run. Now what you're seeing here is actually the UI that MLflow provides on top of the installation. Installation, which is, by the way, very simple. It runs on everything from Windows, yuck, to Linux, to Docker, Kubernetes, and it can connect to a database, it can connect to a file system, and it provides this UI that is also nice for a human to look at. And you can see here I made an experiment. You can see here now, called PyData 2022. And in this list, each of these, you can see them, these timestamp lines, these are the runs. And each run will contain the informations that are encapsulated in this run, and now we'll see how that works. And some code. How do you actually make this happen? Well, it's very easy. You install MLflow as you install any other package in Python, and now it's there. And then we start setting these two concepts I talked about. So the first one being an experiment, super easy, set experiment, give it a name, and now it exists in the database. And then start and then run, again, very simple methods. And now practically what happens, all the code that is wrapped within these two lines will be part of this run. So now we can start using the functionalities of MLflow within this run to start tracking interesting things. But what should I track? That depends, of course. And there is probably there is a whole field that deals with this. Usually when I start, at least when we start a massive, everybody's time constraints, we start taking a look at things in a prioritized way. So we start taking a look, okay, do I have the data quality that I expect? That's the input. Do the output of my models perform in the same way that I expect? So I look at the performance of my models over time in each of these runs. But then maybe also, if I have more time, then maybe I can start taking a look at the code, the configuration, the parameters of my system. Maybe I also want to save the data sets or sample of the data sets so that then later on I can go back in time to 5th of May and see what was the data set at that time? How did it look like? So you can add this also in MLflow run. And again, I mentioned that there is a whole field about it. And again, there were some interesting talks about it, also this conference, the previous days, about drifting. So here the concept is the data will change over time. And there are different metrics that are already established. You can see all the math and the stats online. But they deal with the fact that the input data will change and therefore the outcome of your model will change as well. And the ability to be able to track these things over time, so to track what is actually called also stability, which is the change in this data drift, the way it's called, it's very important. We'll not talk too much about this because it's a whole section by itself. Here we're going to talk about how to actually make it happen once you have decided what are your metrics. So let's start taking a bit of a look. So here now again, I have my start and then run, and let's say that I have all my code inside that is doing whatever things you need to do, data processing, cleaning, training, and whatnot. And now I want to start logging some metric. And it's actually pretty easy. You just log a metric. And this is practically just going to add one line of log in this one run of this experiment. And here, for example, I'm taking examples of things that I actually do. I track really basic stuff like what's the training set size, what the validation set size. So perhaps I want to see how they change over time. I want to start also maybe look a bit of some basic quality checks. For example, how many rows I've dropped. For example, I had some nulls that I had some rules for and I decided to drop them. How many empty prediction labels I had. So how much corruption is in the data. Of course, again, this depends. If I want to go a little bit more dense into it and I look at things like drifting, like I mentioned before, there are also established metrics. Again, we'll not look into that. And for example, I look at one feature, what's the PSI, JSD, distance. You can track literally whatever you want. Of course, here it depends on how eventually you use them. But MLflow gives you the ability of tracking this kind of metrics within a run that is time-stamped. Therefore, it gives you an idea of how things have moved over time. Just interesting here, metrics are just key value pair in the MLflow world, so in Python I can just consider them as a dictionary and save them as log metrics, and I save all the metrics that I want, which is pretty convenient. Just a side note of a thing that I like, context managers. MLflow actually provides one. Right now I was showing start and then run. Easy thing, but it just makes the code a little nicer. You can actually use a context manager like the one that I'm showing here, the start run. So now all the code within this context manager is within the run. Probably you've seen other context managers before, like with OpenFile and whatnot. Really handy tool. And it's also pretty smart because it handles crashes, for example, which is a basic thing. So if something happens within this context manager, then MLflow, for example, an exception, then MLflow recognizes that the run did not end and tags the run of this experiment with a special status failed. So you also know that something happened when you're looking into it, which is nice. You can also log tags. So far we talked about metrics, so things that you probably want to track over time, but it can also be interesting to tag descriptive tags for your runs. For example, don't panic, or for, what kind of model you used, what kind of parameters have you tried. You can think of whatever kind of descriptor you want to add to your run, you can. And you can also add, if you have time for it, you can start logging configuration and data set. We mentioned about it before, with two other concepts, the one of artifact and the one of logging the dictionary. So for the first one here, log artifact, this is anything that is not now, for example, a metric or a tag, and it's practically a file. So in the database world, this would be a blob. You just practically have the possibility of associating to your run any file. And here I have a really simple data set in this dictionary with information about planet Earth, and I'm making it into a JSON, and then I'm saving it in the file system associated to MLflow, and MLflow connects it to my run. And the same if I have a configuration, and in Python, it's often, again, key value pair, and it's a dictionary that I have here. Then I can log that with log dict and pass in the configuration, and again, it gets saved into the run. Now we talked a lot about all the inputs of the process, but there is also the output. So what's the performance of the model? This is something that when we are developing, we are working on a lot. It's kind of the main KPI of the whole system, and you probably said what are your KPIs in that sense: accuracy, F1 score, precision. You know how to do it. All that part is very easy, right? But how do you track it? Well, it's practically just yet another metric in MLflow. So now, on top of being able to know what's your accuracy when you are in development, if you actually manage to track it over time, thanks to MLflow runs, then now you are able to know over each of your trainings how the performance changes. But it's actually, there is an interesting parenthesis here, that, yeah, you can track these things manually, the way we've seen them, but MLflow has a pretty cool tool, which is the possibility of interfacing with the major machine learning libraries. Think about scikit-learn, PySpark ML, TensorFlow, all that kind of stuff. And the way it works is that it has an auto-logging feature. Practically, metrics that are exposed by, for example, in scikit-learn, the fit, the predict, the transform methods, they get automatically saved into the run. This takes a bit of the control away from you, but it gives you a head start, so you can get a hint of what is that could be interesting to track. And the way it works is, again, very simple. Here I have X and Y super simple data set. I enable the MLflow Autolog. Also notice I did not actually say that what package I'm using. It will recognize it automatically. And then when I instantiate within a run a linear regression model coming from scikit-learn, and then I fit it, automatically some basic metrics will be saved. You can see here in this run that I'm showing, it saved, for example, the mean square error, root mean square error, the score. It added some tags about the description of the model, linear regression. It also automatically saved the artifacts connected to the model code. So a lot of things that are done automatically for you. So it also gives you a bit of a start if it's the first time that you're doing these kind of things. Now, we have tracked all our metrics over time, and perhaps things are going on every day and we're tracking new metrics. But personally, I've been in this situation before, both traditional software and ML, where I have a whole database full of logs of information, but it's actually just sitting there and nobody's looking at it besides, once in a while when a crash happens and then I have to make an SQL query. So how do you actually solve that? the first thing that we do when, at least at Massive, when we are setting up this kind of project is that we want to be able to have continuous online monitoring on it. So in most cases, this means a dashboard. And Python has a lot of great options, so many of them, panel, Streamlit, Voila, Plotly, Dash, and they're all great. But actually, I'm lazy, so this is going to be very anti-Python. I don't want to code it. If my dashboards are really simple stuff, I'm like, maybe I can just do it with drag and drop. And actually, Grafana, another open source project that is currently really healthy, provides that kind of thing. So again, it's a system that you can install literally on anything, and it's super light. And it contains plugins for both connections to all sorts of things and plugins to display all other sort of stuff. And how does it work? Here I have an instance of Grafana running on a Docker image. And practically here you're seeing, these are two, they call them panels. These are just time series of showing the metrics that I've saved. And you can see here this one on the bottom. Maybe the tags are a little small, but practically I'm showing run over run, each of these points in the plot. It's the training set and validation set size. So this allows me to see over time very clearly how things are going for these two basic metrics. You can do all kinds of fancy stuff when you have more advanced metrics. But again, being able to see things online over time is not necessarily enough. Now, yeah, data is not sitting in a database, now it's sitting on a dashboard, but am I going to look at this dashboard every day, 24/7? No, maybe I want to set something like alerts. This can be basic and very simple, but I've not always done it. But the cool thing is that Grafana has the concept of alert. So again, very easy, it's just an interface, and the concept here is that you can set a threshold on the metrics that you're displaying, and if the value changes above or below, you can set all kinds of rules. Then it can set up a notification, because again, it has concept of notification channels to Teams, Slack, email, whatnot, so that you can also be notified, on top of being able to actually see how things are going. And just to give an idea of how simple things are to display these values, the plugin was there of a time series displayer, and all I had to do was, for example, in this case, to connect to my Grafana MLflow instance. I'm connected to the REST API that MLflow is providing. You can see here I'm passing the URL of the runs, and then I just need to find the right metric. So it's a JSON that I'm receiving back, so I can use a simple JPath query to look into the metrics of the run, and then I just have to look for the key, for example, in my case, training set size that I'm practically writing here. And once I find that key, then I can add a column, which is the timestamp and the value of this specific metric. These are things that are coming from the JSON response of the REST API of MLflow, and then they get visualized the way you just saw. So the connection is really easy because these plugins are already in there. I'm not saying Python is not easy. Just a little bit of a wrap. The initial question that I asked at the beginning was, do I need to monitor ML, machine learning? I say yes. My experience has been like a great advantage to all the projects I've done after the time in which I was not doing it. It's as important as developing it. If you really want to start thinking and you're working in the kind of scenario where you really want to think of productionalizing your models, then you definitely want to start taking that kind of load off your shoulder of always having to be like, oh, things are not working, and then I only find out when things are crashed, and then I have to go back. On the other hand, if you're asking yourself this question and the answer is no, you're only doing research and you want to stay in your notebook, don't even think about it, right? Go ahead. This is a lot of overhead. Why would you do it? But be careful. Are you really sure things are not going to go in production? Often they do before you expect it, because then all of a sudden you're producing some really interesting value and somebody's like, okay, next week this is going. And like, oh, and now you are stuck on a system that is not monitored, and now you are the monitor, and probably we've been there. And the nice thing about, hopefully, the things that I've shown is that things are actually pretty easy to set up. So you can have a monitoring system on top of your run if you're working with Python, pretty straightforwardly. And a bit on the other side of things, we know that often if you're working with product owners and project managers, they need maybe there needs to be a little bit of education also in the field. So all we've been thinking so far was the development part of a project, and then this kind of, all these things around it, they can get a little bit forgotten. The problem is that in machine learning, things are going really fast, and now what a data scientist would do in their days, maybe it's not enough. Maybe they want to focus on the actual research, and that's why there are now different profiles like machine learning engineers, machine learning operations engineers, of course, data engineers. So consider that things take time and educate the people you're working with on the fact that there is a whole cycle on top of the actual development if you really want to produce value, but you also want to be safe that whoever you're producing your value to is actually getting what they wanted. If you think this stuff is cool, which I hope you do, you can get started with MLflow on the page. They explain how to install it on any kind of system you are on. The same for Grafana, super simple installation, and you'll find the link in the slides. You can also find for Grafana some really cool dashboard templates if you want to get started real quick. If you want to contribute, they're both open source and very healthy platforms. So again, links to those. And we got to the questions. We have time for it. So I hope you do have questions. If you want to contact me, you, first of all, can check. The slides will be on GitHub, but I guess they'll also be on Slack somehow, if I send the link. You can try to write me on LinkedIn, but chances I'll answer are scarce. But if you really want to contact me, then you can do it on PlayStation. That's my username. Or if you want to play The Division with me, which is a great game, I'm not saying just because I work with it, then on Ubisoft Connect, I'm there with that username. Hope to see you there. And thanks.
Thanks, Davide. Questions? I'm going to try and pass the mic around.
Thanks, Davide. We're also big fans of using the tracking feature in MLflow. However, as you said, these other three pillars, as you might want to call them, we rarely use them, and we tend to use rather custom deployments for model serving. And I was just wondering, what's your opinion on the model serving feature in MLflow? Have you ever used it? Would you recommend it for a particular use case, something like that?
Yeah, good question. I think that in my opinion, while the monitoring part is nice because it can you can connect it to anything you're on. Let's say you're using some other stack, like you mentioned, then it's kind of easy to get that one on top. The other ones are more kind of a or thing. So if you're already on some other platform, it's not that obvious how do you use the MLflow serving. I don't have that much experience because ourselves we also use another platform, but I think yeah, it kind of really depends on what's the rest of your entire stack if you're really able to use the other parts, especially the deploying one. For example, the other ones, the one about model registry, that's also easy to interface with something else because it's kind of in that one you are tracking the models over time. But the deploying one, I guess it's a bit trickier, I would say. So.
Thanks for your talk, Davide. I had a question about logging in the MLOps lifecycle. So do you have an open source tool you recommend for that, or are you using something else?
Good question. So for logging, you mean?
So all of your processes, they produce logs, then you send them somewhere. You want to look at those logs. What do you use for that?
And and I guess here you mean things that are not ML flow related.
Yeah, not MLflow. Or it could be MLflow too. You could redirect MLflow to send the logs to that process.
Yeah.
For example, we're using Elasticsearch, but we obviously pay them. If there's an open source tool, I would consider it.
Question. No, we actually don't use that kind of service. We keep our logs, and then we have our very custom ways of getting information out of it. So we create practically our own Python scripts that look into the logs and put them into dashboards, and then we save metadata and we do it. But actually, we do it very custom, which is kind of sad. But I think it's because there are not really a lot of options, as far as I know.
Yeah, that's the experience we had too.
Yeah.
Hi, thanks for the talk. For someone starting out in MLOps, which are some communities he could be part of?
All right, so I think this is a good one. There is a lot of things happening also in the PyData meetups. I see this topic coming out more and more. There are specific conferences on MLOps as well. I think one is called MLOps World, which I have not managed to get to, but I see it's growing over time. Like compared to 3 years ago, it's getting bigger and bigger, and they keep having more and more events. So I think that's one of the main ones. And yeah. Over here, they're saying MLOps community, and it's actually just called MLOps community. Yeah, podcast. Nice to know.
Thanks for your talk. I was wondering, because I've been playing around a bit with MLflow in the past around monitoring models during training. Are you also using MLflow to monitor the data drift you have at prediction time? If you are not continuously retraining your models, you still might want to have some monitoring on how the input data and the output of your models are evolving over time. Do you have any, have you been using MLflow for that also?
We are. So, I mean, here, I guess it goes back to what I at some point mentioned, that if you're tracking drifting, which can be like a complex thing to track, it really depends on your domain, what kind of things you want to use. But, well, we do use MLflow for that. So we track it as other metrics. And of course, this can be in conjunction with other things, like, for example, what they talked about. Great expectations, which can set some rules on how your drift is changing. But they kind of fulfill different things. So we use MLflow mostly for monitoring how things are changing, and then maybe you can have all kind of other things that set like stoppers or like tests on top of it. But yeah, we do.
I think, this is going to be the last one.
Thank you very much for the talk. How would you, when would you sort of start thinking of hiring MLOps engineers into the team, and sort of rather than having maybe data scientists look at what you just shown? So basically, when it becomes maybe too much, that you really need to have full-time people looking after these things?
Very good question. I'm actually the first of the MLOps engineers at where I work. I think it's hard to say it was the tipping point, but the thing is, if you are starting to, let's say you are a data scientist, which is kind of like what in the past used to be the major title, but then you're starting to spend your time with things like, I need to deal with infrastructure, and now I have all these models online, and I need to make sure that they're running, and I need to, and log in, and the data has to be able to, be served to the model over time, and you're actually spending more time with infrastructure. Let's say more than 50% of your time is spent in infrastructure than actually working with the data itself, or working with the model and thinking about business cases and being able to research. That's probably you want to start thinking that maybe you need somebody that supports you in that. Of course, it also depends how many, for example, things you're running, like how many models. The more you have, the more you will have to spend on making sure that things are running at the same time. So it's kind of hard to say, okay, now you need it, but think about yourself and the work you're doing in your team, or because data scientists and machine learning engineers, they want to work on different things. So it's also about self-fulfillment. Are you actually doing the things you wanted to do?
Thanks again, Davide, for that talk.
Thank you.